Following up from the previous video on simplifying algebraic fractions, we're going to look into how to multiply and divide algebraic fractions. After multiplying and dividing them, you can then go on to simplifying them like we've done. But in this video, we might simplify a bit differently than what we've done before. So multiplying and dividing fractions in general is much easier than adding and subtracting them. So you just need to remember the two rules. So it's tempting to make the denominator the same when you're multiplying and dividing, but actually it's much simpler than that. So if I have, for example, x squared over 4 times 2 over x plus 1. Multiplying fractions means that you just multiply the numerator and you multiply the denominators together. That's it. It's as simple as that. You don't have to make the denominators the same. You don't have to do any of the any extra step here. Now I will just multiply them as such and then simplify, and then I'm going to show you a quicker way of doing this. So the first step is to multiply these two. So I have 2 and then x squared. And then just be aware of this. Remember in the previous video I mentioned that actually numerators and denominators have a hidden bracket that we don't write. So actually you're multiplying 4 by this whole thing. So I have 4 times x plus 1. And now I have a single fraction where everything's being multiplied. Multiply here, multiplying here. Now if I expanded, it would be a bit tricky to simplify. Not impossible, but just it would add more complications. So actually now that everything's being multiplied, and I'm going to keep this as a bracket just to ensure the multiplication, I can cancel things top and bottom, and I can look at the numerators first. So I can cancel the 2 and the 4, and that will give me 1 over 2. And I don't need to write the 1. Now the x squared and the x plus 1 do not cancel out. Remember, you can't cancel the x squared and the x because this x belongs inside this bracket. If I wanted to cancel this x, then I should have an x plus 1 exactly identical here. So if you want to cancel anything inside the brackets, then you have to have an identical bracket in the numerator, which I don't. So this does not simplify, and this is my final answer. Now we could have gone from here to here much quickly, and remember the condition that I keep on saying, is everything being multiplied? And in this case, if you notice, yes, this fraction is being multiplied by this fraction, which means I can cancel things numerator and denominator. We've never canceled things in the same location, so I've never canceled 2 things in the denominator or two things, I've canceled them out in the numerator. I've always canceled numerator and denominator. And we can do the same thing here just because it's a multiplication. So I can cancel the 2 and the 4. So I'm canceling numerator and denominator because there's a multiply between them. I can cancel out here if I could, here if I could, but in this example we can't. So we can only do it because it's a multiply. So again, this goes once, this goes twice, and then you do the normal multiplication. X squared times 1 would give me x squared, and then 2 times this bracket would give me such. So, and you don't need to expand it if you don't need to. So if you're not required to. And that's it. So multiplying fractions is actually easier than what it seems. You could just use this trick if you want to, or you can simplify later on if you want to. Just remember these details of you can't just cancel things in if they are in fractions, in brackets, sorry. Now dividing is also not too impossible to do. You just need 2 additional steps before you start. So if I have 2 over x divided by x cubed over 5. So dividing fractions, please do not just divide by x cubed and x divided by 5. That's not how it works. And the concept of dividing a fraction on a fraction is slightly different. We're not going to get into that right now. There are some really nice videos and diagrams that could explain to you what dividing two fractions actually mean, but I'm not going to do that right now. So the way we teach dividing fractions is, you can remember KCF, or I sometimes teach it as KFC, which is you keep the first fraction, you don't change it. You flip the second fraction, and then you change the sign. So the division becomes a multiplication. So KFC. So we keep this as it is. We flip this fraction, so it completely goes 5 divided by x cubed. And then we change the sign, so this becomes a multiply, and voila, we have a multiplication now, and we know how to deal with multiplication. We just multiply across, so I can multiply these two. First I need to look at, is there anything I could cancel out? Remember, this is a fraction, there's a multiply between them, everything's being multiplied, I don't have brackets or anything. 2 doesn't cancel out with anything here, 5 doesn't cancel out with anything here, so nope, there's nothing to simplify. 2 times 5 is 10. X times x cubed will be x to the power of 4, and if you notice, that's as simple as it gets. I can't simplify it any further. So quite a nice example to have here. I'm gonna put up 2 examples which you can pause the video and try, and then I'm gonna go through them. So I could try example 1 would be something where we're multiplying fractions. So let's try 3 fractions. So I have 2a squared times 9. Okay, I should have written them as fractions. This is over 3, this is over a, and this is over 5. So you can try this out. And then the other example would be something on division. Okay, so you can try them out and then watch how I do it. So for the first one, you can look at 2 fractions individually if you want to. You can do all 3 if you can keep track. You could also just multiply them across and then simplify if you want to, which I'm thinking might just be a more straightforward method. So you can see that I can cancel the 3 and the 9. I can't cancel the 2 with anything else. Note, I can't cancel the 2 with the 2 here, remember, because you can only cancel numerator and denominator, and those 2 are in the numerator. So first of all, everything's being multiplied. Even in here, everything's being multiplied. And 3 and 9 can cancel out. The a can cancel out with either. So a lot of things can cancel out. But let's all just multiply them across. So let's multiply the numbers first. So 2 times 9 times 2. That will be a 4 times 9, which is 36. And then I have, let's multiply the a's first. A squared times a squared, that would be a to the power 4. And then b times b, that would be b squared. And then 3 times a times 5, so that would be 15a. And then I can just simply divide by, I can consider the numerators first, so I can divide this numerator by 3 and this numerator by this denominator by 3. The a's will cancel out, so this a will cancel out. I'm left with a cubed here, and b doesn't cancel out, so I'm at the end left with 12 a cubed b squared over 5. That's it. Okay, over 5. And I can't simplify it any further. That's as simple as it goes. As for the second one, we follow KFC first, so I'm just gonna, we do not cancel anything out just before you do the KFC. It's not a multiply, remember. So now that I have, I'm gonna simplify before I multiply. So I know I have a multiply, everything here is being multiplied, nothing in brackets, and I know the 20 can cancel out with the 5. So if I divide by 5, It's going to give me a 1. This is going to give me a 4. A cubed, there's nothing in A here, so I can't cancel it out. B squared and B cubed can cancel out, so 2b's and cancels with 2b's here, so I'm left with 1b here. And now I could just multiply across. So 4a cubed times, this will be a 1. Remember, it doesn't disappear to a 0, it disappears to a 1. 4a cubed times 1 will leave me with 4a cubed over b times 1, which is a b. Now, we could have just gone 20a cubed b squared over 5b cubed, and then you could have cancelled these out. And this is something you could have done as well. But I also want you to see how it's done across before you multiply. So hopefully this video was clear. The next one's going to be a bit tricky, where we're going to deal with adding and subtracting fractions.